All right. Transformations of exponentials and logs work exactly like transformations of any other type of graph. So we've already talked about transformations, about moving graphs up, down, left, right, stretching them out, shrinking them down. All right, we've already talked about them. The rules are not any different. It's just we're starting with a different type of an equation for this. So a vertical translation. It does not matter whether you were talking about a log, an exponential, an absolute value, a quadratic, a line, whatever type of equation you have. If you add a number to the end of the function, it is going to shift that function up or down that many units. And it will go in the direction you think it's going to go. So if you add 3 to the end, it's going to move the graph up 3. If you subtract 7 from the end, it's going to move the graph down 7. So let's write down a log example and an exponential example so we can think about what this looks like. So if I have something like f of x equals 2 to the x power, that is an exponential. The 2 is just the base. It doesn't do anything. It's just part of the parent function here. If I want to move this up 5, all right, then I would add a plus 5 over here to the end. It is not added to the exponent, it's added to the end of the function. Okay, so that would be an example with an exponential. A log example might look something like this. I'm going to call it g of x equals, I might have log base 3 of x. And if I want to move this down 3, I would put a minus 3 out here on the end. Now, this right here could be written this way because if I don't have parentheses, the parentheses only go with the one thing behind the log, right? But it would also be totally acceptable to write this one this way where we've got an x in parentheses and the 3 is over here on the end. Okay? And let's see, let's add here that this would be up 5. This one right here would be down 3. Okay, if there are no parentheses around that x, then it's assumed it's on the outside of the parentheses. Everybody good there? All right, we also can shift things left or right. Doesn't matter what type of function you have. So here it's just a generic function, f of x plus b. This is going to shift the function left or right b units in the opposite direction of the sign. Okay? So an exponential example is going to look like this. If I have a function that is an exponential, I'm going to call it f of x equals, let's do e to the, if I have, let's see, e to the x, if I want to shift this to the right 1, okay, if I want to shift this to the right 1, I would need to put a minus 1 up here in the exponent. Okay, that would shift this graph right 1. When you have the exponent up there, there are not parentheses around that exponent, but it behaves like there are parentheses around the exponent. In fact, you can put parentheses around the exponent if you want. You don't have to for that. That would take the graph of e to the x, it would shift it to the right 1. A log example would be something like this. G of x equals, we would have maybe like g or log base 5 of parentheses x minus 2. Okay, who can tell me what that would do to the graph? Like I've got log base 5 of x. What would it do, Fernando? It would go to the right how many? 2. Okay. Questions there? Same rules as before. Looks a little different because we're doing different types of equations. Okay. A vertical dilation. If A, this is a typo right here that we need to fix. This first one right here should not say A greater than 0. It should say A greater than 1. Right there. So fix that on your slide. So right here, make sure that you fix, oops, sorry. Make sure that you fix this so it says A greater than 1. Okay. If A is bigger than 1, you're multiplying by a number that's bigger than 1. It is stretching your graph vertically. It's going to make it taller and skinnier looking. If A is between 0 and 1, it shrinks it down. It makes it shorter and fatter. Okay. The way that this looks for an exponential is something like this. F of x equals 3 times, let's do 1.02 to the x power. Okay. These are very common to see. We're going to see when we start looking at applications. That's because it's the a times b to the x power. There. 3 would be like your initial amount. There. So this would be a vertical expansion by a factor of 3. So it would be 3 times as tall as it was before. A log example might look something like this. 1/2 log x. This particular one would be a vertical compression by a factor of. Alright. And I think this is the last one we're going to look at is a reflection over the x-axis. So a reflection over the x-axis is when we take a negative and multiply by that negative. This is going to flip the equation over the x-axis, which flips it upside down. An exponential example might look something like this. F of x equals 3 to the negative x power. Oh, I'm sorry. That is wrong. That's horizontal. Here, hold on. Don't write that down. It's bad. That flips over the y-axis. It would look like this. Sorry about that, guys. Negative 3 to the x power. There are not parentheses around that negative 3. If you put parentheses around the negative 3, it makes it like really do crazy stuff. If you're using parentheses, they would just be around the 3. And a log example would look like this. Negative natural log of x. Doesn't have to be a natural log. You just have to have a negative out there. Okay. Questions? All right. I'll tell you what, since we've kind of done this before, here's what I want us to do for a minute. I want you guys just to try to answer a lot of these questions in the rest of the examples, okay? I want you to think about it. You can talk to your partner if you want, but I want you guys to think about it, and then, of course, we'll go over it so we make sure everybody's got it like they're supposed to, because I think that might be more helpful. We've already looked at doing these quite a bit. Now, actually, I should do the first example together, because this says tell the parent graph and describe each transformation. Because a lot of times with logs and exponentials, kids think the parent is part of the transformations, but it's really not. So my parent graph here for the first one, the parent graph is the one that you're starting with, like what type of equation you're beginning with. On this one, it is y equals 2 to the x power. In this case, that 2 is not a transformation. It's just the base of that exponent. So the parent graph is just y equals 2 to the x power. So then you would be looking at anything that is not the parent graph. So in this case, that's your plus 7. Okay, Hunter, what would that plus 7 do to the graph of that function? Not right. It's going to be, that's not inside of the exponent. It's not like in the parentheses. It's out over to the end. That's going to be vertical. That's going to move it up or down. So this would be up 7. Okay. Sometimes it's hard to remember those rules. So if you're having trouble, you are definitely welcome to use Desmos to help you with that here. So here's what you can do. You can do y equals 2 to the x, and then you could do y equals 2 to the x plus 7 and see what it looks like. Sometimes it's a little hard to see. The thing that you could really kind of look at for this is the asymptotes of the graph. Zoe, what is the asymptote of the blue graph here? We have a horizontal asymptote. What is that asymptote there? Okay, it would be 0, particularly if I want to graph it. What do I have to type in? Is it y equals 0 or x equals 0? It's y. So y equals 0. Right there, there's that vertical asymptote, right? Okay, I'm sorry, I said vertical. It's horizontal. Never touches. That's beautiful. So one of the best ways to look at how much this has moved is to look at what happens to the asymptote. On that green graph right there, Emma, what would my green graph, what would the horizontal asymptote be for that one? Okay, let's type it in, see if it works. Y equals 7. Yep, I believe so. So that horizontal asymptote went from 0 to 7, so you can see that the graph moved up 7 for that. So the asymptotes are really helpful to look at for these a lot of times. Okay, so I want you guys to try these on your own. And like all of them, not just 2 and 3. I mean like the rest of the notes. See what you can do for the rest of this, and then we'll go back over it to see if we're pretty close or if we're way off for that. And you can definitely use Desmos for the whole thing. Parent is log with a base of 10. You want to put the x with it too there, or else it won't like graph anything because it has to have an x with it. But yes, that's good. You don't have to write the 10 if you don't want to, but it's good that you're recognizing that is base 10. So that looks good. Then what happens to it, Hector? It goes to the right 3. Now, sometimes the graphs are a lot harder to look at than just knowing the rules for these. Because these graphs are, especially if they're like stretched out, are a little tough to see. So if you just say, oh, I've got a -3 in here, that must shift it to the right 3. Then not only will you be much faster, but you'll probably be a little more accurate for these. Another thing is that this is definitely ACT material. If you have to graph this on Desmos and graph all the answer choices and spend a little while analyzing all those graphs, it is going to take you a while to do that problem. Versus if you know your rules, it's right 3. Very quickly you can answer it in seconds. Correct? All right, we okay here? All right, the next one has a couple things going on. Let's see, Adela, what's the parent graph for that? You were close. It's just going to be e to the x, okay? That -4 is going to be a transformation that happens to the graph, because this one's going to have 2 transformations that happen to the graph, okay? Fernando, what is one of those transformations? Up 5. That comes from this number over here at the end. So the number you add to the end moves it up or down, same direction. So up 5. That looks good. Heston, that -4 is doing something to our graph as well. What is it doing? Nope. Right. So if it's in the exponent, it is like being in parentheses, right? That's where our parentheses are, even though they're not written. So it has to go the opposite direction. So even though it's negative, which makes you think left, it goes to the right. So this would go right 4. And it can be at least a little helpful to look at the graphs here. If I graph y equals e to the x, that's the parent graph. That's before it gets moved at all. If I do y equals e to the x minus 4, you can kind of see it shift. Oh, I can at least tell if it went right or left. Sometimes it's a little hard to tell how far it goes, but it definitely went to the right. And I put the +5 over here on the end, and it moves it up there. So you can kind of check yourself by graphing that. Okay, questions? All right. Okay, this one right here, we are looking at our graph here, and I'm going to graph it on Desmos because that's what I see a lot of you doing. So if I graph f of x equals natural log of x plus 2 minus 3, I get this graph right here, and which one of our answer choices matches that? Can't really see both at the same time. Which one did you get? C. Because you can see that, like, I definitely crossed the x-axis. You could match up exact points, like that y-intercept is -2.3. The only one where that seems to be is on C right there. So that is our answer. But I could also just use transformations. Now, when I'm using transformations, it's important for me to know what the parent graph looks like. The parent graph, if I'm just looking at y equals natural log of x, it has a vertical asymptote at 0. It goes through the point 1, 0. Okay? So if I'm just using transformations, Hunter, what's going to happen to the graph right there? Oh, sorry. Whenever we have that +2, how does that move the graph? Not down. It's opposite direction, so it's positive, but will actually go negative. But inside of the parentheses is not up or down. Which direction do we go for that? It's going to be left or right, and it does go the opposite direction. So inside of the parentheses is left or right. This one is going to move left 2. They are very simple rules. Okay? We just have to have them. You don't even have to have them memorized because you can write them on your note card. Okay? But if you ignore the rules, if you just think that I'm talking like foreign things, it's going to be very difficult. If you pay close attention to my rules, it will be very easy, right, for that. Let's see. Carson just came in. Let's see how much he remembers. If I put a -3 on the end, what's it going to do to the graph? Down 3. Very good. Okay. So if I sort of graph right here, I'm going to graph on this middle one. Y equals just natural log of x, has a vertical asymptote here and goes to the point 1, 0, so it looks something like that. That's what just like the parent graph looks like. So when I move it left 2, that vertical asymptote gets moved to the left 2. It's not going to be B because that has a vertical asymptote at 3. Right here, I've got a vertical asymptote right there at 2. So that looks like it's been left 2. And you can also tell it's definitely been moved down some as well. Okay, questions there? All right, Cannon, which one did you get for number 5? A. Okay. And if the choice for A, what would this -2 do to it? Down 2. And what about that +3? What's that do to the graph, Cannon? Left 3. So like your normal exponential, if I graph that right here, normal exponential looks like this, sort of. It has a horizontal asymptote at the y-axis. So definitely, this looks like that's been moved down 2. And I can at least tell it's been moved to the left some, maybe not. It might be hard to tell how much it's been moved to the left, but if you're unsure, you could, go look at the actual graphs here. But both of these, B and C, get moved to the right 3, so that would look a lot different than this. So A is the correct answer for that one. Okay, questions there? All right, Jose, what did you get for number 6? Okay, C, excellent. Again, this one you can answer it so quickly just by knowing your rules. So if you want to go right 4, then you need to put a -4 inside of the parentheses, which is what we see here. If you graph them, you're going to see that that's what happened as well. Okay, questions there? All right, 7. Maze, what did you get for number 7? Is B. Very good. Now, this is a vertical stretch. These are pretty difficult to see, but if you were stuck on something for this, graph it in Desmos and see what your answers look like. So if I graph these 3, here, and look at them one at a time. The way that you're zoomed in can really make a difference here because like the part I'm looking at here is -10 to 10 in all directions. And this doesn't look like it's steep enough, but if you want to check exact points, I got the point 1, 0 right here. Like over here I should be at 4, 1.39. 4, 1.39 would be like here. That's not right. So it's not going to be A. If I go to answer choice B, that looks much better. I got the point 1, 0 here. That's good. I also have, you're checking exact points. So like look right here. Maybe right here. When my x coordinate is about 4, I got 5.5-ish. So I got 4, 5.5-ish right there. That's on my graph, right? Check exact points to see if they match up. If I look at the last one here, this has been moved up 4. if you look at the y-intercept here, it's not 1, 0. So it can't be that one there. So, but all three of those graphs look kind of similar, so it's hard to tell exactly from the graphs match up points for that. Okay, we got a couple more to look at. I'm very interested in what we have on this one. Because this is something that they might be likely to give you on the EOC, and I'm very interested in what we have here. How many of you got A for this one? Okay, A. I see at least one with an A. All right, how many of you got B? Okay, I got a B. All right, how about a C? Okay, quite a few C's. How about a D? Okay, so I could come up with reasons why a student would answer any of these questions, any of these right here. Okay, why would somebody say A? What do you think, Jamaja? Why would somebody say A? The first equation has a -5, so it is moved down 5, right? But we're going from F to G, right? So F is what we're starting with. We're starting with a function that is down 5. Okay? And then we're going to a function, this +3 right here. Sophia, what's that +3 do to the graph? Up 3. Okay? So a person who answered B was probably just looking at g of x. Okay? Probably just looking at g of x. There's reasons why someone would choose A or B. But in this problem, it is saying that we are starting with F, which has been moved down 5, and we're ending up at G, which has been moved up 3. So first of all, if we start at F and go to G, are we moving up or down? Up, because this one was 5 below, right? And then we're going to up 3. And how far is it from one to the other? It's going to be 8, because it's like going from a -5 up to a +3. And your difference there is 8. So C is the correct answer there. But that one's a little tricky because, yeah, you have to pay very close attention about not only your question, but your answer choices as well for that. Because it could have been a different answer if it said g of x is shifted down or something. That would have been different. Okay? And then the last one, Hunter, what'd you get for that last one? Okay, so we are starting with log of x minus 2. So that's what we're starting with. Okay? We are ending up, actually, Zoe, I think I was talking to you about this one and I didn't read the whole question on that. You didn't know either. I know now. I didn't. Should have. You should have stopped me. You should have been like, but Miss Hyatt, that's not what it's asking. All right. I'm sure, trust me, I can tell none of y'all want to do this at all today. But we have to do it because we want to pass Math 3. We want to pass Math 3. You'll be all right. We'll brain break at the end. We'll get it at the end. Our 3 minutes is at the end of class, so y'all get to pack up early. Okay? All right. All right, so this is the starting graph. Okay? This is not this is not what they're asking us about. They're saying F is what we start with, and it's transformed to produce the graph below. Okay? So, this graph that I just graphed is not that graph. Okay? Asymptotes are the best thing to look at for this. So, Heston, what's the vertical asymptote of the graph I have graphed in Desmos, the log x minus 2? What's my vertical asymptote for that? It is 2. And I know it is 2 for a couple reasons. Number one, it looks like it on the graph. Number two, this graph is moved to the right 2. Right? So, usually it's at the y-axis it gets moved to the right 2. So, are you listening on this question? Okay. All right, so our vertical asymptote is at 2 right here. What is the vertical asymptote of the graph that they have graphed here, Zoe? What's the vertical asymptote of the graph? It is at negative 4. So that is like the key feature that is best for us to look at. Right there is x equals negative 4. So if I started out with a function that had a vertical asymptote at positive 2, and I end up with a function that has a vertical asymptote at negative 4, it goes left, and how far? Not 4. What did we start with? We started with log of x minus 2, which had a vertical asymptote at 2. We went to negative 4, and if I'm over here at negative 2, and positive 2, and I go to negative 4, that is 1, 2, 3, 4, 5, 6. Okay? So D is your correct answer. That will not work. That's a guaranteed way to miss it. Okay, questions? All right, so for our last few minutes, rather than giving you an assignment on this, we are going to spend some time working on the practice quiz. It is extra credit. You must get at least a 60 on it to get that extra credit. I don't know if I have it assigned here. Let me make sure. I may have not put it on here. It is going to be on Canvas. You may have to give me a second to publish it. I don't have it published yet.